Hello, everyone. My name is Wei Shao. I'm from Ocean Lab, Bakehouse Health Science. Today, my presentation topic is a classification of a mild communication impairment with the Rondom Forest and the multi-layer perceptron. First and first, what is MCI? MCI is the intermediate stage between the expected cognitive decline of normal aging and the more serious symptoms such as dementia. MCI is characterized by problem with memory, language, thinking, or judgment. It's worth to mention that compared to more severe disease such as Alzheimer's disease, the boundary of the brain structure between MCI and the healthy people is not very clear. So I use the data from the ADNI data set. So ADNI is a multi-site study that aims to improve and prevention and the treatment of the Alzheimer's disease. And I used 106 participants from the MCI group and 86 from the health control group. And they are diagnosed by MMSE and the CDR, meaning mental state examination and the clinical dementia rating. So in overall, I have 192 participants. In terms of our selection, there are some research have shown that the hippocampus and the medial temporal lobe play an important role in MCI. Especially, there was a research published in 2017 indicate that the relationship between the subregion of MTL and the MoCA performance. MoCA is another assessment for the MCI. So I used 6 ROIs, 3 for hippocampus and 3 for MTL. So they are C1, C3, C4, subiculum, and the perianal cortex, interternal cortex, and the perihippocampal gyrus. Next, I use a free server to process the MRI scans with the T1 embedded with the parallel computing on Computer Canada to get the segmentation of the hippocampus subfield and the medial temporal subfield. So as you can see here on the left side, they are the represented image segmentation produced by free server in health control and the MCI group. On the right side, you can see in the ROI segmentation made by free server provide to me. So there are some segmentation on the left hemisphere and the right hemisphere. Okay, let's say the correlation matrix. You might notice that there's no highly correlate ROIs in the MTL, but it is some highly correlation within the hippocampus, especially the C4, C3, and the subiculum. They are highly correlated with each other. As I mentioned before, given there's no dramatic structural change, no matter in hippocampus or medial temporal lobe between the MCI and healthy control. So you can say the volume of those two areas, they're no significant difference between those two groups. The same thing, happened in the MTL. Although you might notice there's a dramatic difference between a left and the right perianal cortex, but in general, there's no difference in terms of volume in those two areas between MCI and healthy control. So next, I use a Rondom Forest. So what is Rondom Forest? It is a classification algorithm considering many decision trees, combined with the multiple decision trees with the different weights and the feature of the data, and then make overall prediction that would be accurate more than any one of the individual trees. So I use Rondom Forest classify with 2,000 decision trees, and cross validation would be 75% data for training and the 25% data for test. Overall, this model has achieved 83 accuracy. On the bottom of left side, you can see there are some matrix to evaluate this model. So for example, precision and recall. So precision is more refers to the ability to correctly reject a person without the disease. So in here, for instance, MCI, so this 0.82 just tells me that the model the Rondom Forest classify had to reject the person who is not belongs to MCI. So similarly, recall refers to ability ability to correctly identify the patient with the disease. So in terms of the MCI condition, so this tells me that how will this random forest algorithm and identify the MCI person actually belongs to the MCI. So on the right side, you can see its important features. As I mentioned before, random forest is more like a ensemble, like machine learning, which means that it has like a compare multiple decision trees. Therefore, it can provide me that which ROI like contribute more in terms of the just modern processing. So there are like three most important features: left say forebody, left speculum body, and left perihippocampal gyrus are most contribute more weight in the random forest model. So I also use a multi-layer perceptron for the binary classification task. The same classification setting in order to do the comparison. So the overall the MLP only achieve 69% of accuracy, and on the right side you can see, and this is my MLP model design. I use two hidden layers and ReLU and the softmax as my active function. So compared to the random forest and the MLP, so I would argue that random forest would be perform better in terms of this binary classification of jobs, especially never alone to mention that when the first is more has been proven more robust, more reliable with the limited data set. So in my conclusion, I would argue that machine learning, especially random forest, would be the potential candidate for the identification of MCI. And but also, however, there is some limitation of my study. The first and the most important thing I would say is the validity of the input data. Some people already argue that the segmentation made by Philosopher is not accurate in some scenarios. Other people also argue that human segmentation could do better job in terms of the quality of segmentation. So which of this leads to the next future study. So I would say maybe we should use another neural image software such as Ashes to do the segmentation job, or like the manual segmentation in order to get the better input data. Also, we could use the T2 with the image and to get a better segmentation of the hippocampus. Overall, I think this just indicate that if we have like better input data and for the machine learning, we could achieve more accurate result. Okay, now this is all of my today topic. Thank you for listening.